Perfect. So, our first talk of the evening is by Mr. Mark Turner, and he'll talk about service mesh. So, big round of applause for Mark, please.
Sorry to interrupt, Peter. My blood sugar's better, but you're all going to be in a carb coma, so I guess, 50-50 on the quality of this presentation. Cool. So, as was introduced, my name's Mike Turner. I have been working with Istio stuff for a while, I guess. I was at Skyscanner where I introduced Kubernetes, and then the next evolution there for us was to look at Istio, so I was playing it back in the 0.1 days. We did not adopt Istio 0.1. There was some, expectation mismatches maybe, and the quality there with compared to what you might want for something you run in production. But anyway, I've been playing with this stuff for a long time. I'm now at a company called Tetrate, and we do service mesh stuff. Some of the old Istio team are working with us, so Istio is our technology bet, but service meshes in general are an area that we think is very promising and that we're focusing on. So just to lay any fears of bias, I do work with service meshes, hopefully that qualifies me. But it's not for everybody, so what I'm going to go through tonight hopefully is, what is a service mesh? Do you need one? Is it right for you wherever you are? Hopefully give you the information to make that choice for yourself in your own circumstances. As they said in the introduction, DevOps is definitely a lot about culture and about collaboration and teamwork and people. But I think there has, over the last 5-10 years, been a sort of revolution in tooling. So a lot of the tooling we do have now for managing infrastructure is just infinitely better than it used to be. And Kubernetes is a fine example of that, right? Terraform, we could list them for a half hour. But I think service meshes and Istio in particular are maybe the latest vanguard in that set of tooling. So let's go through. I'll go over why we're actually talking about this at all, right? What is a service mesh? What problems might you recognise that would lead you to even think about it? How did we get here? These ideas didn't come out of the dark, so what were the sort of formative ideas that led us to this thing of a service mesh? And then I'll tell you what one is anyway, right, for anybody who doesn't know. I'll try to do a demo. I don't have too long, but we'll see how that goes. And then I'll enumerate, I guess, just with slides some of the other features that a service mesh has got, because you can do a lot of different things depending on what your needs are. We'll look at some of the common forces against service mesh adoption and whether they're appropriate for you. And then I will try to give you an answer, but as I say, that's only ever going to be my opinion. By way of a quick pop quiz, I don't really know what kind of talks we normally get at this meetup. Who is using Kubernetes? Okay, cool. That's pretty advanced. Who's heard of this joke? Who's tried it? Okay, cool. Anybody running it in prod? Right. Cool. No, okay, this is good. Hopefully this talk will be relevant for you. Okay, that's pretty good. Everybody knows what Kubernetes is. The demo will at least make sense, I hope. So why do we care? Why are we even talking about this service mesh thing at all? This actually goes back to what problem are we trying to solve? What is the business value of investing in IT and spending all this money in forgoing our bonuses to pay down the technical debt, build something for the future? So there's various things that businesses value. Two of the big ones, I guess, are sort of speed of iteration on products and features, the sort of the classic time to market, and then reduction in risk as well, reduction in the sort of technical risk of rolling those features out, causing an outage, and then the reduction in the risk of a new feature not being the right thing. And that's all about how quickly you can experiment, how quickly you can get it out, how quickly you can roll it back. So what we want is short, fast sprints and releases. So we broke the monolith to do that, right? This is the age-old story. We had a single rock, a big rock, and we broke it in half. So now what used to be one big monolithic piece of software, maybe a big Spring Out with a bunch of namespaces in, well, we've now taken, maybe we've rewritten it as we go, but we've taken the same sort of basic functional units, and we're now running them maybe in Kubernetes. So we've got all our own code. It's the same architecture as before often, but it's just spread out across the network. So it is maybe the same shape, the same packaging, but it's just got more failure modes. Because if if we're not careful, we can take that monolith and we end up with a distributed monolith, right? It's not real microservices unless you add a bunch of extra components, because what used to be a method call between, Java methods in classes and namespaces now becomes a network call, and that can fail in so many different ways. So we really need to be able to sort of observe those calls, to monitor them, to control them, to retry them, to secure them, a whole bunch of stuff. So how do we get there? What attempts have been on our journey to microservices? What attempts have been taken so far to make this reality? Well, remember back in the 90s, if anybody's as old as me, you had to have a user who would use a web browser maybe to talk to a server that would serve you some information off the database. Right? This is a three-tier software architecture with a user talking to it. Some people were even lucky enough to get traffic, to get user growth. So they bought a bigger computer. You would go to Sun or IBM or Oracle, you write them a big check, and you would get a bigger computer, which would let you service more people at once. But about sort of sometime in the computers suck is the problem, right? So around sort of sometime in the 90s, we gave up just buying bigger computers with more redundant power supplies in. I think sort of Google started it really in the public domain, and they just bought more computers. So they bought commodity hardware and they expected it to fail, and they designed their systems and wrote their software such that it was okay for it to fail, and they had lots and lots of this redundant commodity hardware, and some of the scaling was about, and some of the extra computers were about adding scale, but some of them were about adding that buffer for resiliency as well, because we're not just spending more and more money on ECC RAM and all of that jazz to try to stop this failing. We expect some of this stuff to catch fire. And then on the software side, we did the same kind of thing, right? So whereas we took our big one server and broke it down into a lot of cheap x86 motherboards, we took our big monolith and we broke it into microservices, as I'm sure we all know. So here we got one service, maybe this is the user-facing one, calling another bunch on the back end. But what happens if the service breaks? Or, of course, if we're in the modern cloud, your service could break, your pod could break, your kubelet could break, your host could break, your region, your zone. So many things could be on fire under this because we're at such a level of abstraction that, as far as the user is concerned, there is a service that is not talking to us, and there could be 1,000 reasons why, and there could be correlations with breakages of 1,000 other different services. So that causes, massive sort of cascading failure scenarios and massive propagation errors if we're not too careful. What do you do when that service catches fire and everything else times out, and then load goes up on other services and then whatever? Quite often your user just gets a 500, right? It's shitty, but it's common. So they'll hit retry, they'll blame their 3G connection or whatever. Better systems will time things out. They will retry those calls, they'll throw circuit breakers and go elsewhere. So I say one of the ways we try to tackle this problem, one of the ways we got here is through these sort of libraries and frameworks for our programming languages, in-process stuff. So Netflix released a bunch of their stuff as OSS, Eureka and Zool and whatever. It's all very good. There's Akka. I was a massive Akka remoting fan myself back in the day. There's microservices frameworks, right, for Go or whatever. There's APM systems for monitoring your workloads, especially in complicated languages with their own VMs like .NET and Java. Observability like tracing, and then of course the big ones, I guess. I actually had my Hystrix, obviously is Netflix, but Finacle and Hystrix, where I guess if you're a Java, especially Spring Shop, those were the big libraries that you turn to give you network retries and timeouts and deadlines and all that stuff without actually having to write the code yourself. So all of these things, shared in common some sort of must-have primitives. They did service discoveries for you, so you sort of could late bind between your microservices. You didn't have to hardcode in IPs or hopefully even names. They gave you fault tolerance through circuit breakers and back pressure or whatever, and they added some observability. And this was all code that you didn't have to write. This was all code that came in these libraries. One of the main drivers, one of the main things that's happened recently is we're in a polyglot environment, right? And this talks again, I guess, to the organizational change as well. There's a proliferation of languages with nice frameworks that we might want to use. This is all good, science experiments are good. But also, I feel like organizations are empowering people a lot more and letting teams be more agile, be more self-contained, be more self-managing, and make a lot more of their own decisions. That, to me, is a big part of the DevOps culture. But as a result of that, one of the sort of major side effects was this proliferation of different programming languages that people used, right? And it seems like a simple thing, it seems like a good thing, but what if we were relying on those in-process libraries from before? Hystrix and Finnegal, the two big ones, they're JVM only, so your Scala, Kotlin, Java if you must, but they're not applicable to a Ruby or an Elixir or any of these other, fancy things that you're using to attract the, you're writing your services in to attract the smart young grads. The other way I would say that we got to where we are today is declarative infrastructure, right? So there's been a move to cloud, to public cloud, systems where we now have more of these computers because we're running at bigger scale and we're using smaller ones, more smaller ones. And these computers fail a lot, so we're treating them as cattle, not pets. I'm sure you've heard that 1,000 times. So I feel like, this has been happening for decades, but back in the day we got sort of servers under control with things like Ansible and Puppet and Chef. And then, they didn't even necessarily have to be our servers anymore. We could be renting them from Google or Microsoft or Amazon. And then we put an API in front of that, right? We made all compute look the same by running Docker for a single machine, by using Kubernetes to run Docker on multiple machines. And then Terraform gives you that uniform API over your networking and your storage. So all the old nasty standards for SDN and software-defined storage and stuff, hopefully kind of going away. The big point about all of this stuff, this is the tooling side of DevOps, the big point about it is that it's all declarative. So you write a description of the pods that you would like to be running, you write a description of the VLANs, the VPCs, the security groups that you would want, and something takes a diff and applies it and makes the world look like you want. And you can run these things on a CD system. I'm sure I'm preaching to the choir here. But the point is, there's been an API stuck in front of it, and it's declarative. So I can have a single source of truth, a source-controlled definition of what the world should look like. That definition is thrown at an API, and some magic agent does some magic, and then the world looks how I want. So I would say that a service mesh is kind of the best of both of those things. So we have these in-process libraries that take away the communication difficulties that we might have, right, to turn our distributed monolith into a proper set of microservices that is resilient, that is observable and monitorable and controllable. But it's, if you think of, so that's an application feature, I guess, but it's also maybe part of the infrastructure. If you think of a network as part of the infrastructure, there's not too much a layer 3 network can do for you. Right? The internet, IP is BGP, IP, whatever, are very clever. Within an application of yours, you actually want different sort of features. So by bringing those things together, we get to the service mesh. So what is the service mesh? Now we've sort of watched both stories through I guess operations and development. Maybe they even got together to give us DevOps. What is this service mesh thing? So a service mesh adds a proxy, an HTTP proxy, a network proxy to each one of your services. So whereas these might have been Java processes before, right, and we put the Hystrix library in them, and we defer to Hystrix to call between to manage the calls and the network traffic between these services. Now the service is a self-contained Unix process, this little box on the left, and we put a proxy alongside. So the thing doing the network traffic is separate. It's not just a separate library in a sort of separate Spring Boot container thing, widget, whatever they're called. I'm not a Java guy. It's a completely separate Unix process. In fact, it's a separate container. So for people who know how Kubernetes works, this would be a Kubernetes pod. Pods can contain more than one container. But one of the distinguishing features on the pod that makes them so powerful is that each pod has, all the containers in the one pod just have one network. They have one network interface, one IP address, and they actually have one set of IP tables rules, which is what lets all of this work. So this sidecar is strapped alongside your process. Your process just makes dumb network calls, and it just tries to do RPC to something else, and it doesn't have to have any code, any logic to care about whether that call fails, to produce logs for it, to produce metrics for it, anything like that. And this proxy sits in the pod, and it intercepts it, and it does all of that stuff for you. As I say, it's an HTTP proxy, so it works up at layer 7. It understands the semantics of a get and a post. It understands it can retry gets because they should be idempotent. It understands, in the general case, it can't retry posts because you might be altering something. So you get all of those advantages from being up at layer 7. So you can kind of think of it as a layer 7 overlay network if you want. If you're, I guess, an operations infrastructure-minded person. person, or if you've come from more of a software development background, then this is Hystrix, but this is in a completely separate process, and this is being LD preloaded effectively. If anybody knows what that mechanism is. And then, so strictly speaking, this is a service mesh. This is a mesh of services. Any mesh of services is a service mesh. But in this definition, a mesh of services with this proxy added to make that mesh powerful and useful as a service mesh. What makes it actually usable to us is adding a control plane. So a piece of software that will go and configure each one of those proxies for you. Because you could imagine doing this yourself, right? Anyone who's ever set up sort of Nginx to do path-based routing for their toy project or for a company network, right? It's essentially done this. So you could have more than one copy of Nginx, and you can put one next to each of your application servers. This is how Nginx Unix works. This is how Varnish works, right? But the manual configuration of those things is quite hard. And maybe back in the day, we would push config to those things with a chef or a puppet. The difference with, so this is obviously Istio, and Envoy is that's the Envoy logo, sorry, I should have said, that pink thing, that's the proxy that Istio uses. There are competing products. There's Linkerd from Buoyant, which has their own control plane system down here, and their own proxy, which is actually really Rust, it's very neat. Console has started doing one called Console Connect. So the important thing is you have this data plane and control plane, just like Kubernetes, right, has the kubelet and the API server. You have the data plane doing the work, adding all those features I talked about, and then you have this control plane on the front, pushing configuration updates to these things, keeping everything in sync, and this has an API on the front, and this API is declarative. So you throw it, YAML files, they're actually the same format as kube YAML files, they have an API version, a kind and a name. You throw it those kind of YAML files, it does magic, it works out what the state of the world should be, the state of the world actually being the configuration for these proxies, right, in terms of host and path-based routing, timeout, retry policies, etc. And that's how this system works. So can I take questions at the end? That might be quicker. Because I'm going to try to give you a demo. Doesn't always work. Okay, so I've got. I'm not too brave, so I've got a bunch of scripts right, that take you through this. There's actually a GitHub repo of all of this for anyone else to play along home. I've run up to number 4, I promise. So I basically brought up a Kubernetes cluster, I've downloaded Istio, I've installed Helm's Tiller into it, I've installed. You sure? You're going to have to review that.
I'm hoping so. I've installed
Istio into it. Okay, so the next thing I'm going to do is just throw in an example application that comes with the Istio source code, which is called bookcode. So this is I'm just doing a kubectl install, kubectl apply. Why are they all terminating? That's terrifying. That's not a good sign, is it? This might be quite a short talk. Don't understand. That one had a bad day. Kubernetes to the rescue. That one, maybe VM was on fire. Well, there you go, book info. Don't know what happened there. Kubernetes is great, isn't it? That's not part of the demo. So this is running on a fancy houseman. So this bookkeeper thing is running actually very good. All this does is install some sort of Windows configuration. Yeah, I thought I helped myself out on that.
Right, so Book Info is this example bookstore. It gives you, we're reviewing one book, we've got details of the book, we've got reviews of the book, like pros, and then these star ratings. So yeah, it doesn't do a huge amount. If I keep refreshing it, the one thing you'll notice is the star ratings come and go. Sometimes they're black and white, sometimes they're color, sometimes they're not in existence. That's because there's 3 versions of this. These are all different microservices, so these ratings come from a microservice. There's 3 versions of ratings. Like one doesn't give you any stars, one gives you monochrome stars, one gives you color stars. No, actually, I think there's 3 different versions of reviews, but you choose whether to call that this or not. But anyway, there's 3 versions of something. There's one Kubernetes service in front of all of them, so standard Kubernetes round robin. Standard Kubernetes round robin, you get about an at random. So, I think it's due out. Yep, so it's right like I just went through the browser. Yes, there is. You also get a 200. So the first thing I can do is, as I say, Istio takes these Kubernetes-style documents to declare its configuration. They literally live in the Kubernetes API server. They're declared as CIDs. So when I install Istio, which I didn't do now because it takes forever, it installs hundreds of CIDs. Lets you tell Istio all kinds of things. So we just keep Istio applied a thing called a destination rule, and that's an Istio type. So this is telling Istio about the 3 different versions of that rating service, right? Some of which give you stars and some of which don't. And it can do that because it sits at layer 7. So all Kubernetes knows is it's got a service and it's pointing at everything that matches the label like app equals ratings. But what we can do with Istio is because we can see the HTTP host and the path and any other headers, we can actually distinguish between calls that end up in these different places. So I can tell it. And I also need to it does actually tell you about the pods as well. So I can say, well, you've got 3 different versions of this thing. I know there's just one Kube service, one with it fronting it, but these different pods do actually have different labels on them. So there's 3 different versions of this service. So this isn't too exciting. This is saying, okay, even the details thing's got 2 different versions, and guess what? V1 is identified by a Kubernetes label version of V1. So we've done that, but this is just telling us what's going on. But now I can create some more Istio types that say, actually, every time you hit reviews, because we were getting those 3 different, maybe we were doing an experiment with star ratings. Most people actually want to get version 1 because that's presumably the stable one. So what I can tell Istio now is when you want the rating service, everybody's just going to go to V1 because it's on the wire. Right? Kubernetes couldn't really do this unless you change that service description, change the Kubernetes service object, change the label selector, which can get a bit tedious and isn't as powerful as we'll see Istio can be. What I've told it is every call to the rating service is going to go to those subset of pods that have a label, so there will be one. And there's more. I've only got 25 minutes. We won't read them now. You wanted to see maybe chart me out later instead of iambic pentameter. So far, I'll prove it works first. Right? There's no stars. No stars. No stars. No stars. So far, nothing we couldn't have done with Kubernetes. Right? I can change the label selector in that Kubernetes service to add that extra label to reduce the subset of pods you can just leave up. But where we come in being on wire and operating at layer 7, parting and understanding of HTTP. So I can start saying something like this, which is, if I'm to use a JSON, why not? I want to see V2. So there's one YAML here that says basically, hey, up at the HTTP layer, if JSON's logged, if you've got a header called end user that exactly matches JSON, so if there's a cookie that's basically logging JSON in, then when you want that review service, you're going to go to the V2. I told you earlier how to identify V1 and V2. I want you to go to V2 instead. Otherwise, you go to V1. So, no stars, no stars. If I look against JSON, of a plain HTTP with a super secret password. Stars. V2 is the black stars, right? V3 is the red ones. And also JSON, always black stars. So what we've done here is sort of an A/B rollout or a canary. You can think of it as something like that. The JSON example is a bit stupid, but this could maybe be users in a particular region. This could be 1% of users. This could be anybody who's running an alpha browser, right? Because they're the kind of risk taker who obviously wants to opt into your canary test. And if your website doesn't work, they'll just play in the browser, so you don't have any reputation damage. This is anything you can do. Any HTTP header or attribute, a combination of them you can think of, we can do. Because A, this thing is in the right, so there's no application code changes to this at all, right? You've got a proxy, it understands HTTP in a way that Kubernetes, kubeproxy, Calico, we plan all of them because they're layer 3 networks, they just point out. I think that's okay, I'll just use one just in time, use metrics. So the other thing that proxy can do is, because it's on the wire, is seeing what these network calls, it can generate logs and metrics and trace bands for them as it goes, and it can do that transparently. It's that you get that for free when you put this thing in play. When I installed Istio, it not only installed all the proxies and the Istio control plane, it actually installed an instance of Zipkin, and it installed an instance of Prometheus and Grafana for metrics, as we'll see, and it installed a logging server as well. So this little script is just support forwarded. But this is a port forward into the Cube cluster. This is just a port forward into the pod that's running Istio's Grafana, right? That's Istio's Prometheus. And now mesh wide, let's go generate some traffic. Back to those stars. Very clever. I've now got for free I think these things are 5-minute moving averages, so I probably can't move the needle. But we've got 0.3 ops a second across the whole mesh, right? There we go. So generate some traffic. 100% non-500s because nothing's failing yet. NA percent 400s getting any. Yeah, and you can see that reviews isn't really being called because I've now logged JSON out, so we're not making that call to see what the star rating should be. So you can get all of these metrics, right? It's standard red metrics with a few different latency values, and we kind of get them for free. So this is across the whole mesh, and I'm running short on time, I think. But the other link would have been for particularly just per service, so you get red metrics per service. We could have drilled into any of the services. Thank you so much. Cool. That's what I'll do. So hopefully that shows the sort of end user value of Istio, why this would be useful to an operator, why this would be useful to an application owner. And although you didn't see the steps, the fact that this is free, you can go see the book info code. It's up in the Istio GitHub repo, and there is none of the code to support any of this in any of those applications. They're each in a different language. They're all really simple. I mean, they're like one file of Python, one file of Ruby kind of thing. I'm going to go back. That's the whole view though, isn't it? Because oh, well, I didn't even need to. There we go, I had a joke. I didn't even need it. G-card close, stayed up. So, don't have a huge amount of time, but a service mesh can do a lot more than the introduction that I just showed you, right? So as we saw, you've got all of those proxies, they can generate observability statistics, they send it. What happens is that they all send the observability, the logs, the traces, and the metrics, they send it to the Istio control plane, and then that thing can be configured with, guess what, more CRDs, to actually send those anywhere you want. So it's almost like an adapter for them. So all the proxies generate these things, the control plane sort of aggregates them. As it happens, because this is a self-contained demo, the metrics were going to a Prometheus instance that Istio had installed.
had been deployed with Istio, and that we were seeing that with the Grafana instance that Istio had also installed. But you can configure Istio to say, right, when you get all those metrics for the proxies and you've aggregated them, I want you to send them onto CloudWatch, or I want you to send them to a Graphite database over there with this IP, right, inside of Kubernetes if you're running it, outside of Kubernetes. So Istio then becomes kind of an integration point, and it gets you all those statistics and traces and spans, and you can configure it with one or many logging metrics and tracing servers. So a lot of, on AWS, you would probably say, I want to send all the logs, generate a log per RPC, a log per network call, and send it to CloudWatch, right, and send the stats to CloudWatch metrics if you're really bought into Amazon, for example. It can do traffic management, as we said, so I'm showing a few different things here. I can do an 80-20 split for like an A/B test. Again, there's above and beyond Kubernetes. If you wanted an 80-20 split in Kubernetes, you would need a multiple of 5 of the pods, right? If you think about it, because you can do the splitting with the service, but it's basically going to be round robin. So the only way to do it, to do, for example, 80-20 in Kubernetes, is to have 4 instances of this pod, one of this, or 8 and 2, etc. Have one service that points at all of them, and rely on round robin to get in aggregate 80-20. We can do this in Istio with 2 pods, because Istio is actually on the wire, so we can have one of each, or we can just say, send 20% to this pod A, 80% to pod A, and 20% to pod B, because it can make that decision every time. We don't have to wait for a sort of emergent property of a slightly crappy round robin. It can also do canarying down to 1%, and you can just say something like, well, this is the new version, so the 20% that goes over here, I actually want, rather than 20%, I want all the traffic from, there's 1,000 instances of this, right? So all the ones that are labeled staging get to hit this new version of this other service. All the ones of these that are labeled prod still go to the old one, because Istio can talk to Kubernetes. It has the knowledge of whether your pod is in, because the proxy will say, hey Kubernetes API server, who am I, where am I, what are all the labels on the pod that I'm in, so it knows whether it's in prod, it knows whether it's in staging, it knows what zone it's in, it knows what security context it's in, and they can then say, okay, I'm in prod, so I want to call the old version of the service, and I want to add a specific header, I want to add a header to it, for example. You can do all that stuff. As I say, more traffic management, it can throw circuit breakers, it can impose rate limits, global rate limits, which is really cool. So say this is a service, if there's 10 copies of this pod, we can say that between them they only get 50 requests a second, right? So if the bottleneck isn't this pod, but the bottleneck is the single database, so this thing's horizontally auto-scaling, but the bottleneck is the one database that they all talk to. So actually the HPA is kind of a bit useless. What we need to do is limit the number of requests into all of these things so that they can't spam too much into the database out the back. You can do that kind of global rate limiting, or you can say, service B can make 50 requests a second to each, service C can make only 10 because it's an experimental thing. All of that stuff is possible. And as I said, this is all declarative, so this is one of the more simple pieces of YAML I could find. We've already seen it in a terminal. This was the thing about JSON. So we're declaring that everybody gets version 1 except JSON. So all we do is we write these documents that says this should be the state of the world. And it's not, if anybody's ever configured Nginx or even Apache, but it's not too difficult. Here's your host. There's no path in this route, but they could be. And then on the destination, the whatever Nginx calls it, the backend, the cluster is that review service, but that's the V1 subset that I defined to you. We can do security in the form of access control lists, so we can say that this service is simply not allowed to talk to these two. Maybe nothing in staging is allowed to talk to prod except for the exceptions I make. Maybe service A's business logic just has no reason to call service B's business logic, so we will fail safe and we will not allow any calls except for the ones that we program in. So these ACLs are available under an RBAC model, right? A role-based access control model, so you can put services into roles and then give those roles power. We can do mutual TLS. So again, there's 1,000 layers of abstraction here. the data in this call from here to here could be getting leaked. It could be getting leaked on the network because one of the million layers of networking abstraction has been owned, or it could be being leaked because one of the pods on one end or the other has been owned, or the kubelet, or the kernel, or the host OS, or the BIOS, or the right. There's now 1,000 layers. So the only way really you need defensive depth, but really a very good thing to do is to actually go to each of these services and issue them a certificate, issue them an X509 certificate saying, I trust you. You are allowed to talk to this guy. So we issue them a cert. It does TLS in both directions, so mutual TLS. That gives you that encryption on the wire, obviously, which is good if the network's been compromised and somebody's snooping. It also gives you the strong authentication, which means that I will only talk to this guy if I know it's claiming to be service B, but I will only talk to it if I know it's service B. So if I've verified the signature of the binary of the container image of the host kernel, not all of that's actually implemented yet, but it's definitely coming. And it does it currently looks at it basically just asks Kubernetes, so it thinks it is these days. But there is a lot of work being done to look at trusted compute environment stuff all the way down the stack through all these layers of abstraction, with the ultimate result being the actual endpoints will get these X509 certs. But you say, I have an edge proxy, I have Nginx doing routing on all of my data, and I retry on behalf of the client. If it fails, what do I care? Well, Istio gives you an ingress proxy. Not only does it put that proxy alongside each service, it can give you a bank of proxies on their own. That'll be your ingress point for you, your classic host and path-based routing. That sidecar model brings a lot of the functionality that we've seen obviously closer to the app. It lets you do sort of inter-service rate limits or whatever that you couldn't do normally, but there is still definitely a place for routing and service discovery, and for more sort of brutal rate limits and stuff at the edge. So Istio brings you an ingress layer. I have an API gateway. Well, like I say, Envoy is a fairly sophisticated proxy. The Istio control plane can tweak most of its knobs, so it will do rate limiting for you. It'll do access control in like an RBAC way. So if you want this path, you can only dispatch that to this subset of services. It will, as of today, I think, well, as of now, it does JWT validation, so it can start to move in, beyond the sort of Nginx reverse proxy. It can start to move into things that a typical API gateway might do. So if you're hosting an API endpoint, a machine readable endpoint on Istio, it'll do JWT validation for you. There's a PR open for it to do the whole OIDC flow, so you can actually direct a user through sort of Google GitHub single sign-on, right, to go through the sort of login with your Google credentials, which behind the scenes issues a JWT, which Istio can then verify. So that OIDC HTML7 flow is coming. It doesn't currently do any of the sort of paid-for features that you get from these big enterprise API gateways, right? So sort of IP whitelisting and blacklisting you can do, but there's none of the sort of automated service you get for updating those blacklists. It won't do sort of anomaly detection, bot detection, and bot blocking. There's no reason why any of that can't come, but it doesn't do it yet. But I have a CDN. You're going to want to keep that, right? It's not a silver bullet. You can use Istio, especially its edge layer, and you can expose it to the internet, I guess. It can be your ingress point up to a point, but you wouldn't want to expose it to the wild internet. You wouldn't want to put this in a POP. You wouldn't want to not have a CDN behind this if you think you're going to get real scale, you're going to get actually attacked. And there's a million other reasons to use a CDN, right? If you have any kind of static content, then having a pod running Nginx to serve that through all of the service mesh and all of the Kubernetes and all of the VPC is not the way to do it. You want to push that stuff to a CDN. So it's not designed to replace. More and more people do seem to be running Kubernetes in sort of points of presence. I'm putting Istio on top of that, but it's never going to replace a CDN. If you've got a website that's like John Lewis, I'm not going to tell you to do that. But have a WAF. You should probably keep your web application firewall again for now, but Istio is a proxy, it understands HTTP, it understands all of that stuff at layer 7. There's no reason it can't do injection attack detection and prevention, cause, XSX. So all of this stuff that, again, would either be in a middleware layer in your app, right? If you're using the Go HTTP server, you can install middlewares for all of this stuff. Or you push it out of process, you defer it to an actual WAF product or to Nginx Plus or something. There's no reason it can't do that. The proxy has a plugin mechanism, and I think mod security Observability are the first people to try to make their WAF into an Envoy plugin. So again, that's coming, but for now, those features aren't offered out of the box. Yep, I have an APM system. I have observability. Again, so we've seen we can get logs, metrics, and tracing for the network calls. That's fine. The backend can be multiple and they can be arbitrary. It doesn't. Obviously, it is a network component. It does sit in a separate container. So what it doesn't give you is the sort of APM insight into the JVM or the CLI. There's no JVM agent here. This is a completely separate thing. So if you've got a fully featured sort of APM system, then you're going to want to keep that as well. And I've got an enterprise service bus. Why do people use service buses? I mean, I need to get off, so I won't philosophize about that. But if you are using a service bus, you're using it for one of many thousand different things, right? If you're using it for retries between your services, for sort of loose coupling, flexible service discovery, late binding of all those calls, Istio can do all of that for you. Istio doesn't have an idea of what a client or a server is, so again, it doesn't really care what your topology is between your services. It doesn't do anything too clever. It just looks at the calls you're making and tries to make them better, so it won't do any kind of broadcast or multicast or pub sub. If you're actually using a bus, the sort of advisor pattern is called, right? The one service puts onto the bus, hey, I want an answer to this, and then arbitrary services will get back to it. Then you can't do that kind of broadcast mechanism. But as long as you're happy with the sort of point-to-point calls, unicast, calling like a standard HTTP call over an IP network, Istio will come along and make that better. So a lot of the things people use ASBs for can also be replaced. So do you need a service mesh? I mean, I've been told to get off. So I'm going to say yes, really quickly. I had to say something. I think the answer is it depends. I hope I've shown you what they can do and told you some of the directions they're going to go in. I think they are. I think it's a good model. I think it's bringing a lot of power today. I think it can bring a lot more power in the future. I think it can give you a lot of business value in terms of taking a lot of that toil, a lot of that non-business logic stuff out of your application code, and then also out of those in-process libraries that are just big, bloated, use a lot of RAM, and need updating often, forcing a redeploy of your app. All of that stuff can be moved out of process. And you don't need to be scared of it, because you don't need to wrangle your own IP tables rules or proxy configure anything with Puppet, because we've moved on. We've got a nice control plane, it's got a declarative API. So I'm going to say, if I was going to recommend one, you probably want Istio. It is the bigger of the set. This is Linkerd. Their dev experience, their installed experience is really nice, but it is, I guess, the flagging product. Console itself, the database, has as many stars as Istio, but Console just released a feature called Console Connect, which is a sort of service mesh. So it uses the console database cluster to do service discovery, and as the backend for all the config management. But the Connect feature, the actual network proxying, is very new. I actually don't have any hands-on experience with it. It is out there. If you're going to do this, you should go and evaluate all these things yourself. Obviously, Istio is the red line here. It's got the traction. It's almost getting the hockey stick. It gets more searches than the term service mesh itself, which is the blue line. It's got backend from Google, Lyft, IBM, Cisco, etc. And it's fairly easy to deploy and use. I didn't show you the install step, but none of those scripts are more than like 3 lines. So if you're on Cube, it's easy. If you're not on Cube, it's possible, but it's not easy. So that's what I talked about. Big stare out. Thanks.
So we have time for 3 questions, so make it count. Yeah, so first one here, Mr. Harvey.
Good stuff, but how do you test all this? How do you take those declarative configs and turn them into a test suite to ensure compliance with what you've called for?
What are you trying to test over and above? So you can run end-to-end tests on this system, right? If you're testing your Kubernetes clusters, if you're doing any kind of end-to-end testing of your microservices, you've probably got a CD system that can stamp out entire new Kubernetes clusters, or at least namespaces, where all your applications are, and then you hit them with representative. On the front end and assert that you get the right kind of calls out the back end. Right? If you add, so I guess my point is you're probably already testing the nodes of your microservice graph. This is changing the edges. So if you've already got a way to test from one sort of node at one edge to the other edge, then if that test suite continues to work in the presence of Istio and your Istio configuration, then that's not broken.
That's not what I asked. I asked, how do you take Istio's definition and use that to drive the tests to ensure compliance? You define your service mesh with its rules. How do you take that rule set and turn that into a test set? Yeah.
Thanks, that's great. I've had a play with Istio, but it seems quite Kubernetes focused. We have Kubernetes and some stuff on just AWS hosts. Can you run Istio in both places and link it together?
Yeah, you totally can. They're going to put a lot of work into this. It's called expanding the mesh. I think that's what you'll find the docs under. So yeah, you can run one mesh. So a mesh is like defined by the presence of the control plane. You can have more than one mesh and you can get them talking to each other. That's a bit ropey. But you can have one mesh. You run the control plane in Kubernetes because that's easy. There's a whole bunch of Kubernetes that'll just install that. Your services in Kube get the proxy. I didn't even say that. That's Psycho sort of injected transparently for free by a mutating webhook permission controller, right? So you don't even have to define it in your pod definition. And yeah, then there's a bunch of docs on how to do it. You basically shell in, well, you make all of your VMs through shell or through Puppet or whatever, install the proxy. You have to install a bunch of IP tables rules to set up that traffic interception manually, but again, they kind of tell you how to do it. And then they can just join as long as they can reach the Istio control plane, which normally involves writing like a kube ingress object so that you can call into the right pod. Those proxies can be told to just go join the control plane. Yeah, actually, it's called mesh expansion. It's a bit manual, but obviously you can automate it with all the DevOps tools. It works quite well. You need one proxy per what would be a pod, so one proxy per workload. If they get a VM each, then it's easy. If they don't, then your IP tables rules become longer. So yeah, you got 3 jars on a node. You will need 3 copies of the proxy with the proxy's not multi-tenant, and the way Istio configures it is multi-tenant. So your IP tables rules become longer, basically.
So I have maybe a silly question, but I hope practical. So I started to learn it and tried column charts and see a huge diff because I tried to use all of the sort of features. So my question is how to start with ready Kubernetes as already quite a big cluster and not get overwhelmed maybe, which how would you, because this hello world example I kind of comprehend, but it's quite big and there's a lot of great features which we actually need quite a few of them, and then it's becoming huge change suddenly. So maybe how would you start in big clusters?
Okay, interesting. So there's a bunch of things you can do. You can install all of Istio as long as your cluster's big enough. So actually, a default Istio installation now does need the pod resource requests are quite high, so it does need quite a lot of space. If you can spare the RAM and the cores, you can install all of Istio, but you can then opt individual namespaces in. So I said that the injection of that proxy is transparent and it's done by a mutating webhook permission controller. It actually doesn't do that at all unless you opt a namespace in. So you put a label on the namespace saying, hey Istio, like inject the proxy into this namespace and effectively join all the services in into the mesh. So if you install Istio, it hides itself away in a namespace called Istio system, and then one namespace at a time you can start adding that label, so you can just get a few of your services on the mesh at a time, right? So everything else in every other namespace will be kind of off the mesh. There'll be no proxy there doing anything, like no, you won't ever have to be second guessing the service mesh if you see strange behavior in those namespaces, if you see what I mean. So you can add your service, your namespaces in one at a time, so particular services or staging or whatever. You can also roll out Istio a period at a time. So I mean, by default, it will do services. It'll actually take the packets and it'll move them around. It's quite good at that. It won't do retries. It won't enforce deadlines. pipelines. It won't do timeouts or any kind of blacklisting. It won't do any of that out of the box. You have to configure all those things by writing a CID. So actually, if you just install it, although if you look at the list of pods and CID definitions, there's a load of stuff there. You shouldn't see any real behavior. It shouldn't actually be doing anything other than being completely transparent and generating metrics like out of the box. If you are worried about trusting that, or if you're worried about the footprint, then there's an initiative called Istio-related, which you can probably Google for, which is basically where they're taking the Helm chart, they're splitting it up into pieces. So if you don't want the MTLS, then you don't deploy any. That control plane's actually made of 4 components. So if you don't want the MTLS, you just don't deploy the component. You don't turn it on, and you don't ever even need to deploy the component that issues the certificates. If you don't want any of the online policies, if you don't want ACLs or rate limits, then there's another control plane component you don't need to deploy, because all of the stuff like APE routing is a more static thing, so it's controlled by a different. I've got a whole talk on how the control plane works, but it's controlled by slightly different. Istio-related is the kind of name of that might be the internal name of the initiative. I think the docs have that name on them. But if you go through the more advanced docs on istio.io, it'll tell you about how to only deploy the parts of the control plane you want. And as I say, if you don't actually turn any of those features on it, it probably won't do anything. That helps.
Great. We have a single sign-on solution deployed that uses user certs and MTLS to identify users. Is it still possible to use Istio with that, or would it break the TLS chain and kind of stop that from happening?
Yeah, that's tricky. It's not just breaking the TLS chain. It's what terminates the TLS at the moment? Is it your sort of an edge proxy?
It goes down to the pod.
It goes right down, right. Yeah. So the thing is, if you're terminating the TLS right down to the pod, the problem is Istio can't do its layer 7 routing because everything's encrypted. They have just added SNI support to Envoy, so it can do host-based routing based on SNIs. You can't do any of the header, so a path is just a header, right? You can't do any of the routing based on path or user agent or any of that fancy stuff. And it can't generate metric. It doesn't know what's a 200 or a 500 because that's in the encrypted tunnel. It will not break. It just will basically be a layer 3 network with where addresses are host names, like SNI headers and not IPs. It can't do much more than that. If you've got that system, the normal thing, the Istio recommended thing to do, I guess, would be to get TLS terminated at the Istio ingress at that edge, because in Kubernetes that's bad. You terminate at the edge, it's then plain text within the cluster, which is probably why you've done what you've done. Because Istio, obviously, its edge proxy will then reissue MTLS all the way to the pod, so you get TLS all the way to that sidecar. And the only plain text you get then is between the sidecar container and the service container, which is plain text, but it's over loop back within a pod, so within a network namespace, within a host, within a VPC. There's also layers of protection. So that's the kind of Istio model. You need a bit of setup, I think, to turn the SNI routing on. But if you do it, it will not work. It just won't be able to offer you most of its features.
Thanks.
Okay. I was wondering the performance impact of having a proxy on each pod for each request we have. We have in a high thought system web page that sells a store. We have problems with the DNS, so we have to choose to migrate from Kubernetes to Core DNS due to the impact of the performance, because if like 30% of the requests we're spending only on DNS resolution. So on Istio, how is the impact for each request or having this proxy that makes logic on the layer 7?
Okay, that's interesting. The DNS thing's interesting. It's proxy, it does a bunch of parsing, it's on the wire, it's not going to be free. In terms of latency, we've run some empirical tests. I've seen it at about 2 milliseconds per proxy. About a millisecond of that is the proxy itself. Another millisecond is IP tables, because you're jumping through IP tables and you're jumping in and out of kernel space like 4 times, right, to get into the network stack, and to be like, oh no, wait, you go to the proxy, up to user space, back down again. So you get about 2 milliseconds of latency from that. The proxy does have a throughput limit. Envoy is pretty quick. It's not as quick as, say, Nginx, which has been doing it for 20 years. So it's obviously depends on a huge amount of things, like how many calls you throw it and whether you've got huge tables turned on and all that kind of stuff, but it's going to have a throughput limit as well. It's fairly high. You might just decide, this is Kubernetes, you might just decide that this is worth it, and even if your app is super fast and Envoy makes it 10 times as slow, or if you enable the horizontal pod autoscaler, you might be prepared to spend 10x the number of cores to get these features, if you see what I mean. So you can kind of solve the throughput problem, as long as you've got a horizontally scaling app. I can wave my hands, and so you can kind of solve the throughput problem by just adding more. You can't solve the latency problem, obviously, and you're talking about too many seconds of a hop. The DNS thing's interesting.
Yeah, we had like a huge impact in the platform, and we thought with Google Cloud because it was in Google Cloud, and they tried to scale up Kubernetes. We reached like absurd limits of Kubernetes, but we had like 6,000 requests per second, and Kubernetes was just like.
And each one was making a DNS request. There was no caching at all.
No, Kubernetes was making a request, and Kubernetes.
But your app wasn't caching it.
No. So we made it Kubernetes. Kubernetes has better performance, but it's not supported in Google Cloud. So we ended having a CDK making all the DNS caching. So we have a DNS mask catching the DNS request in each pod.
So Envoy is basically going to be doing that, right, for you, right? So Envoy will be looking at the host header and then doing the service discovery to find out where that should go. And Envoy will do a bunch of, unless you've got like reasons for having no cache at all, then Envoy will do a bunch of that caching for you. So your application, we should talk about DNS afterwards. It's complicated. You can stop it, and then Envoy will do it. All caching hierarchy architecture in the control plane and the Envoys that I can talk you through that should help a lot.
Perfect. Thank you very much again, Matt.